Hi guys, so today we're going to go over exponential functions. So just note that in order to solve for x, when it comes to exponential functions, we want the same base on each side of the equal sign. So when each side of the equal sign has the same base as number 1 does, we can set the exponents equal to each other and solve for x from there. The reason why is because, and you'll learn this in the next section, the way to get rid of an exponential base of 2 is to give it a log base of 2. And whatever you do to one side, you do to the other. And what happens is this becomes 1 times 3. So the exponent, since there's no longer a base, this is no longer an exponent, equals 1 times x plus 1, which is just 3 equals x plus 1. So from here, we're going to isolate x. It's being added to 1. We're going to subtract 1 on both sides, and we get x equals 2. For the second question, notice that we don't have an exponential base that is the same as the other side of the equal sign. So we're going to look for comparisons, meaning I have a base of 3 on the right side of the equal sign. However, on the left side, I have 27. But I could use an exponential base of 3. For instance, 3 to the third power, 3 times 3 times 3 does give me 27. So I can just rewrite 27 as a base of 3, and I have the same exponential base. So from here, I can just set the exponents equal to each other, and again, add 1 to both sides. And for this problem, I'll get x equals 4. And you can always substitute the x in and check if you're correct. So for instance, 4 minus 1 is 3. 3 to the third power does equal to 27. So you can always substitute the x value to check if you are correct. Moving on for number 3, there isn't a power that I can raise 16 to get 64. So for 16 and 64, I'm going to have to find a common base, meaning something that I can raise to its power to get both 16 and 64. So some of you will just have to kind of play it out in the calculator, try 2 as a base first, then try 3, then 4. You can also use the multiple choice answers to your advantage. So in this case, if I test out 2, well, 2 to the fourth power does give me 16. So I'm going to change 16 to the fourth power. It already has an exponent now of 2x plus 5. So I'm going to bring down that exponent, which is an expression, notice the plus sign. So I'm bringing it down in parentheses. The reason why I'm choosing a base of 2 is because if I test out 2 to the fifth power, that doesn't give me 64, but 2 to the sixth power does. So if I try out 2 to the sixth power, that will give me 64, and now I have bases, exponential bases that match. So I'm going to bring down the exponents, and then we have 4 times 2x plus 5. So distributing, we have 8x plus 20. Bring down that it equals 6, and our goal is just to isolate x now, so we'll subtract 20 on both sides. Always get rid of adding and subtracting first. We have 6 minus 20, which gives me negative 14, equals, bring down the 8x. And finally, x is being multiplied to 8, so we divide it on both sides. 14 and 8 don't go into each other, so I'm going to reduce it by dividing both by 2, and that'll give me negative 7 over 4, which equals to x. So for number 4, I'm going to write this out just so it's a little clearer on what the problem is. So first of all, not only do I have bases that don't match, I also have a fraction going on. So we're going to stick to the original plan like we did for number 3. We're going to find a base that matches. So the good thing about 125 is if I raise 5 to the third power, meaning 5 times 5 times 5, that will give me 125. But since I don't want to deal with the fraction, remember, if you want to move something from the denominator to the numerator and vice versa, you change the sign of its power. So I can change this to 5 to the negative third power. If this was something other than a 1, I would also keep the numerator here, but since it's just 1, I'm going to leave that alone. And it equals 5 to the x minus 1 power. So since I have the same base, I'm going to bring down the exponents and set them equal to each other. Negative 3 equals x minus 1. And then from here, I'm going to add 1 to both sides to isolate x. And I have negative 3 plus 1, which gives me negative 2. All right, guys, I hope this helps.